This lesson covers quadratic functions in standard form and their graphs. The standard form for the equation of a quadratic function is f of x equals a times x minus h squared plus k, where a, h, and k are real numbers with a not equal to 0. The graph of a quadratic function is a parabola with its vertex at the point hk. The axis of symmetry is x equals h. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. Let's graph the quadratic function f of x equals x squared minus 4x plus 5. We'll begin by writing the function in the standard form a times x minus h squared plus k. So we have f of x equals x squared minus 4x plus 5. To write this function in standard form, I'm going to put the x squared minus 4x in parentheses, leave the plus 5 outside of the parentheses, and think of what number I need to add inside the parentheses to complete the square. Well, to complete the square, we take half of negative 4 and square it, giving us plus 4. And to keep this right side of our function the same, we need to, if we're adding 4 here, we need to subtract 4 as well. Okay, so we have f of x equals x minus 2 squared plus 1, and the function is in standard form. Let's next find the vertex and axis of symmetry with our function in standard form. Remember the vertex, if we have x minus h squared plus k, the vertex is hk. And so here the vertex would be 2, 1, the point 2, 1 on our graph. The axis of symmetry is x equals h, so here our axis of symmetry is going to be x equals 2. Next, we will find the x and y intercepts. To find the x-intercepts, we set y equal to 0. Okay, so we have x squared minus 4x plus 5 equals 0. This does not factor, so we will need to use the quadratic formula where x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is going to leave us with the square root of negative 4, an imaginary number. This tells us that there are actually no x-intercepts on our graph if we come up with an imaginary number. Okay, what about y-intercepts? To find y-intercepts, we set x equal to 0. That gives us a 1 y-intercept at y equals 5, which will be the point on our graph of 0, 5. So let's graph this function. Starting with the vertex of 2, 1, then the axis of symmetry, x equals 2. Next, the x-intercepts, we don't have any. In fact, our graph opens upward, which we could see a equals 1 here, a positive number. The y-intercept is 0, 5, so if I put the y-intercept on here, my graph is symmetric about this axis of symmetry. So if I have the point on my graph of 0, 5, on the other side of the axis of symmetry, symmetric to this, would be the point 4, 5 on the graph. That helps me get a fairly good graph here of this parabola. And this is the parabola for our function f of x equals x squared minus 4x plus 5. Does the vertex 2, 1 yield an absolute maximum or absolute minimum? So this is what our graph looks like. The point 2, 1 is an absolute minimum. It's at the very lowest point on our graph. What is the absolute minimum? At the point 2, 1 here, the y value is 1, so the absolute minimum will be y equals 1. Try this on your own. Graph the quadratic function g of x equals x squared plus 2x minus 1. Find the vertex, the axis of symmetry, and the x and y intercepts.